video we're going to look at factoring quadratic equations. That's going to be our focus here. How to factor out quadratic equations. And we're going to look at, I think in this video, the case where we have we're adding and we have a positive coefficient. So we're going to have some number times the variable x squared plus another number times x and then plus c. So we're going to look at, in this case, where a, b, and c are all positive and we're adding and adding. What do we do? How does this work? Well, what's nice about this, if a equals 1, so if we have something like x squared, if you just see an x squared, a equals 1, plus, 5x plus 4. Well, this is our function, our quadratic equation. We could write f of x or y, doesn't matter. Y equals all this stuff. Well, here a is equal to 1, and b and c, b is equal to 5, and c is equal to 4. Everything's positive. Well, when we have this situation, it's very easy to factor out, because we know right away that, and you'll get a better sense of these as you mess around with them and play with these equations, but the idea is that if these are both positive, 2 pluses, then when we factor out, we're still going to have 2 pluses. And since a equals 1 here, we have x squared, we need to have just 2 x's there. And I'll show, when we go through this, I think you'll see why. But again, if you have 2 positives, we're going to have 2 positive signs in our factored equation. The next step is to look at the constant 4 and the coefficient 5. We want to find factors of 4 that add to 5. And you'll see why when we distribute the two terms in this quadratic. You'll see why that's important. But always what we're looking at is, if we can do it, what factors of our constant, our number right here, add up to our coefficient. So the factors of 4, we've got 4 times 1, and then we've got, or 2 times 2, or we can do negative 2 times negative 2, or negative 4 times negative 1, but we don't want negative 2 times negative 2 or negative 4 times negative 1, because when we add up 2 negatives, we still get a negative, and we need a positive 5. And actually, the only thing that works here is 4 times 1, because 4 times 1, if we add them, we get 4 plus 1. So if we add up 4 and 1, we get 5, and that's going to be our answer. So we can put the 4 here and the 1 there, or reverse that. Either way, we're done. We factored this equation. And this is incredibly useful because once we factor it, we can figure out the 0 values. So we started off with x squared plus 5x plus 4 equals y. And then we factored it into x plus 1 times x plus 4. Or we could write it as x plus 4 times x plus 1. And that equals y. Well, we always let y equal 0 to try and find the roots. We talked about that in other videos. This equation right here, it goes along and it crosses the x-axis twice. Those are the roots. So, and that's when y equals 0. Here's our y-axis. At these 2 points, we're on the x-axis, so we have no height or depth below 0. We're at 0. So that's when y equals 0. So we let y equal 0. And now we can figure out what those two x values are. Because x plus 1 times x plus 4 is 0, well, that means that x plus 1 is equal to 0, and x plus 4 equals to 0. Because, either both of them are 0, because 0 times 0 is 0, we're multiplying here, or one or the other is 0. So to figure out what we need to plug in to get those zeros, we say, well, x plus 1 equals 0. So x could be negative 1. That's my negative 1. Let me fix that. And then x over here is negative 4, because negative 4 plus 4 is 0. So we factor out, we set this equal to 0, and we can tell that the two roots of this equation are both negative 1 and negative 4, or one or the other. And we can plug in to check. We'll talk about that a little bit later. But again, the idea here is to factor. And you can tell this works, we can check, by using the distributive property. The way that would work, and I mean, there are lots of shortcuts and ways to look at this, but I just like to kind of think about it. We have x plus 1 times x plus 4. I remember that the distributive property says you have to take every term and multiply it by the other terms. So x here has to be multiplied by this x, and by that 4. So it's x squared plus 4x. And then this term, we do the same thing, but we have to distribute it to the others as well. So 1 times x is just x, and then 1 times 4 is 4. If we combine x and 4x, we get 5x. So our new equation is x squared plus 5x plus 4, and that was what we started with. So this worked. Now our strategy for when we have all positives works even when a is not equal to 0. So like, let's say you get something like this. 6x squared plus 18x plus 12. Okay. And this will set equal to 0. What do we do? Well, even though a is not 1 here, we can notice that, or maybe we notice that 6, 18, and 12, well, 12 and 18 are all multiples of 6. So we can make our lives easier by dividing everything by 6. We have to divide both sides by 6 in each part to keep this equation balanced. So 6x squared divided by 6 is just x squared. 18x divided by 6 is 3x. 12 divided by 6 is 2, and 0 divided by anything is still 0. So we've taken this equation and simplified it to this. Now we can use our same strategy as before. X's go here, everything's positive, so all pluses. Factors of 2 that add to 3, well, 2 is prime, so 2 and 1 go in there. So that was easy, right? This, once we get rid of that 6, if we see a common factor, we can divide by 6 in this case, right? We can divide by the common factor in these multiples, and then we reduce our equation to something a little bit simpler, where this number here, is equal to 1. And that makes our life easy, because then we can just have these two x's here as well. Now sometimes you can't do that, but we might look at examples of this in other videos. When you can't simplify it to just 1x and make the coefficient here in constant, nice whole numbers, you have to do a little bit more planning when you factor out. And this will give us our original equation. Let's just check that. We distribute these two terms by multiplying them to these two terms. So x times x is x squared. X times 1 is x. 2 times x is 2x, and then 2 times 1 is 2. That equals x squared plus 3x plus 2. And that was our original equation. So we did factor it correctly.